Hello students, welcome you all in Sudhi Jaiswal Edu Maths. So in the previous class we have discussed about the system of linear equation, how we can represent it as Ax equal to B form. If you have not watched this video, then I am giving you the link. Okay, please watch this video first before watching this video. So if you have Ax equal to B, where A is represented as, you know, that the coefficient matrix, okay, coefficient matrix, B is the variable matrix, okay, and X is a variable matrix, and this is the constant matrix, okay. So this is actually the representation. So if here you see B is not equal to 0, if B is not equal to 0, so we call this whole system of linear equation is non-homogeneous, okay. The whole system of linear equation is non-homogeneous. So if it is like this, so the first condition, if B is not equal to 0, like I can give you a case like this: 2x plus 3y plus 5z equal to 9, 3x minus 3y plus 5z equal to 7, x plus y plus z equal to 3. Okay, so here you see that the B is not equal to 0. What is B? The constant one, 9, 7 and 3. B is not equal to 0. So how you can write it like this? Here A is what did I write here? Coefficient matrix. So coefficient of x will be in the first column, 2, 3, 1, 2, 3, 1. Coefficient of y will be in the second column, 3 minus 3 and 1, 3 minus 3 and 1. Coefficient of z will be in the third column, 5, 5 and 1, 5, 5 and 1. And what is x here? The variable, okay, x would be here, the variable matrix x, y, z. What is the order? Here order is 3 cross 3, here order is 3 cross 1, 3 rows and 1 column, and the B is called constant matrix, which is 9, 7 and 3. So here you see that the constant matrix is not equal to 0. So in this case, if you the first case is if determinant of A is not equal to 0, then the system of equation is consistent. So what do we call it? The system of consistent, all right, and has unique solution, all right. Write it. If determinant of A is not equal to 0, then consistent, the system of linear equation is consistent and unique solution. Suppose if determinant of A is equal to 0, then you have two cases. The first, adjoint of A. First you find adjoint of A into B, okay, then B into B, okay. If you get adjoint of A into B is not equal to 0, then what would happen? And if the second case, if you get adjoint of A into B equal to 0, then there are two cases, okay. So there are two cases. The first, then if you find adjoint of A into B non-zero, then what would be it would be inconsistent, okay. The solution would be the system of linear equation would be inconsistent, and you can say there would be no solution, okay. And if you find adjoint of A into B is 0, then the system of equation is consistent, and what would happen? And has infinitely many solutions, So learn it. So the question is, how would you solve this? So how would you solve this if adjoint of A? So we'll do it later, okay. The solution is you would get 3 equations, okay, and you can solve it. So in this way you have to take z equal to k, and if you take z equal to k here in this case, then you solve two equation and find the value of x and y in k, all right. you're not getting, then I'll tell you. The second case, if B is 0 here, so it would be called homogeneous. If B equal to 0, then it's called, the system of linear equation is called homogeneous. So in this case, if the system of linear equation is homogeneous, the cases are here. If determinant of A is not equal to 0, then what would happen? Okay, and so you can say that A inverse exists. In this case, A inverse exists. So it is non-singular. That means determinant of A is not 0. So here you have system of linear equation Ax equal to B form, and here you have what? B equal to 0. So now you can write it as the constant as 0. Okay, 0 matrix, not 0 matrix it is. Okay, so A inverse exists here. If you find the first case, if you find determinant of A is not equal to 0, then A inverse exists, and what would happen? The system has, you can say the system of equation has the unique solution. Okay, and system of unique solution, write it, unique solution, and solution would be like this: x1 equal to x2 equal to x3 equal to, I think, xn equal to 0. Okay, the solutions are like this, and this is called trivial solution. Okay, this is also called trivial solution. Okay, the second case, if determinant of A equal to 0, then what would happen? Then it would have infinitely many solutions. How? Yes, then you need to find adjoint of, no, you don't need to find anything. Adjoint of A into B would be, in this case, what is this? Since adjoint of A, what is B? B is 0 matrix, so it would be 0 matrix here. So in this case, if you find determinant of A equal to 0, the system of linear equation is homogeneous. Okay, then the system of linear equation will have infinitely many solutions. So infinitely consistent and infinitely many solutions. Okay, so again, how would you solve if you find infinitely many solutions? In this way, you have to put z equal to k. Okay, and solve first two equation, and you will, if you solve the first two equation, you will get the value of x and y in k. Okay, and if you, okay, so whatever value of k you will take, you will get different value of y always. So the system of linear equation will have what, infinitely many solutions in this case. So in this way you can solve, but I'll also give you the example, and I'll okay, system of linear equation has infinitely many solutions. Okay, all right, so here we have the first question. Okay, so let's solve it. The first question is 3x plus, sorry, not plus, this is minus y minus 2z equal to 2, 2y minus z equal to minus 1, 3x minus 5y equal to 3. Okay, so what do you have to do? You have system of linear equations, your three equations you have. So what do you have to find? You have to find the value of x, y and z if it is consistent. Okay, so we have to solve this. So whenever you see first, what is this? This is system of linear equation. There are three variables x, y and z. Here the b2 minus 1 3, which is called the constant here. First try to solve A. What is A? Is the coefficient matrix. Is the first column, second column and third column. First column is for the coefficient of y, so coefficient of x. It would be 3, 3, 0. If it is not in this, if x is not in the equation, so we would consider it as 0, and 3. Here minus 1, 2, minus 5. Okay, and coefficient of z is -2, -1 and -5. What is this? Check it out. 3, 0, 3, -1, 2, -5 and -2, -1, -5. Alright. What is X variable matrix is what? X, Y, Z. And what is B is the constant matrix 2, -1, 3. Alright. Now first you have to solve for determinant. Okay. So determinant of A, how would you solve? So you have to write like this. Okay. 3, 0, 3, -1, 2, -5, -2, -1, -5. So what would you do? So you do first write here plus, minus and plus like this. And what do you do here? You write +3, okay, 2 cross 2, determinant here, then minus of -1, okay, so minus of -1, 2 cross 2, minus, it is plus here, plus of -2, 2 cross 2 determinant. Okay. So what to do? How would you get this determinant? So you are focusing on +3. Remove first row and first column. What did you get? 2, -5, -1, -5. 2, -5, -1, -5. Okay. -1, remove this row and this column. Okay. Corresponding row and corresponding column. Okay. So when you remove it, you will get here 0, 3 and -1, -5. 0, 3, -1, -5. Okay. Here plus -2, remove this row and this column. What would you get? 0, 3, 2, -5. 0, 3, 2, -5. Solve this. How would you solve? Left cross minus right cross. -5 to the -10, minus of -5 into -5, -1, 5. Minus +1, left cross 0 minus right cross -3, so it would become +3. Plus -2 here, 0 minus 6. So here 3 into -15 plus 1 into 3, 3 minus 2 into -6 -12, it would be +12. So here -45 plus 15. So what is the answer? -30, which is not equal to 0, non-singular. Okay. So it is -30 or not? I don't know. Or it is wrong. What is this? So here we have 3x minus y plus 2z equal to 2, 2y equal to -z equal to -1, 3x minus 5y equal to 3. So here the answer is determinant of A is equal to 0. But how? Okay, 3 minus 1 minus 2, 0, 2 minus 1, 3 minus 5, here 0. Oh, sorry. So sorry. So 0 here. Okay, all right. So you can 0. Okay. You got here 0 minus 1, 0. When you remove it, you again get 0 here. Okay, all right. Yeah. So 0, 0. So it would be -15. Okay. -15 and +15. You'd get 0. So here you get what? Determinant of A is what? Singular. So determinant of A is singular here. So what do you do now? So here we check for what? Adjoint of A into B. Okay. How do you find the adjoint of A? In order to find the adjoint of A, we have to first look for the cofactors. Okay, since we know that the adjoint is the transpose of cofactors. So how would you find the cofactors? So the to find the cofactors, you need to write C11, C12, C13 all. So what should we do? Remove this, okay, for the space. So you write C11. What is value of C11? Minus 1 raised to power 1 plus 1, and you get minor here. Minor is what? The determinant of the sub matrix after removing the first row and first column. 2 minus 5 minus 1 0. 2 minus 5 minus 1 0. Are you getting? So its value will be here, the positive even power. So here 0 minus 5 will be minus 5. C12, okay, first row second column. So how would the formula is? Minus 1 raised to power I plus j, means 1 plus 2, and it is minor. You get, it is the determinant of sub matrix you obtain after removing what? First row. This is first row and second column. You will get here 0 3 minus 1 0. 0 3 minus 1 0, like this. Okay, so it would be, you would get negative because negative power of odd number. So 0 minus or minus 3 would be 3. Okay, so minus 3 you get. C13 minus 1 raised to power, again y, the same thing, 1 plus 3, and you get the minor here after removing first row and third column. 0 3 2 minus 5, 0 3 2 minus 5. So it would be here a positive value, and get left cross, means 0 minus 6 minus 6. All right, again you need to find what? The C21. What is C21? Minus 1 raised to power 2 plus 1, and you get after what? Minor after removing second row and first column. So you get minus 1 second row and first column. Minus 1 minus 5 minus 2 0. Minus 1 minus 5 minus 2 0. So in the same way, so you get here what? Minus 1 raised to power 3, the negative value. So 0 minus here you would get minus 10. Okay, so in the same way, when you solve this, I have the values here. I am going to write it directly. So here all right, so cofactors would be here. C is equal to, here I have the values here, minus 5 C11, C12 minus 3 minus 6, I have obtained this. 10 I have obtained here, 10 6 12, and 5 3 6. Okay, and what is the adjoint? What did I find there? This is C21. C21 is the second row and first column. Minus 1 minus 5, what about that? Minus 1 minus 5 minus 2 0, minus 2 0. What did I, so minus 1 raised to power 2 plus 1 2, yeah. So it would, here you get negative value. Okay, I think, and when 0, left cross minus right cross, 0 minus 10, and when you solve this, you'll get 10 here. Okay, all right. Yes, it is right. This one is right. If I want to find this is what? Third element of third row and third column. Okay, this is C33. So how would you find this? 333 is actually minus 1 raised to power 3 plus 3. Okay, I plus j, and the minor you obtain from after removing third row and third column. What would you get? 3 0 minus 1 2. 3 0 minus 1 2, and even power positive 1, and 6 minus left cross minus right cross, 6 minus 0, 6. Okay, all right. So in this way you can find the minor. I hope you understood. And now what is adjoint is actually a transpose of this cofactor. So just transpose it. So in the transposition, the rows becomes column and column becomes row here. So minus 5, minus 3, minus 6 will come in the column here. This row 2 will come in the second column. Row 3 will come in the third column. 5, 3, 6. And what is B here? B is your 2 minus 1, 3. 2 minus 1, 3. We need to find the product. The order is 3 cross 3 and this order is 3 cross 1. So what is our first rule? We have to check the column should be equal to row here, okay, and the order you get the product you would get in the order 3 cross 1. So what is the product? Okay, let's solve it. So here the row would be multiplied with the column. Okay, how? Minus 5 would be multiplied by 2. Minus 5 into 2 minus 10. Okay, minus 10 plus 10 into minus 1 minus 10 plus 5 into 3 plus 15. Okay, again minus 3 into 2 minus 6 plus 6 into minus 1 minus 6, again 3 into 3 plus 9, minus 6 into 2 minus 12 plus 12 into minus 12, and 6 into 3 18. So it is minus 20 plus 15 minus 5. So here we are we on the right track or not? I think maybe. So it is not equal to 0. We have to find whether it is 0 or not. Okay, we don't have to. So it is minus 20 plus 15 minus 5, minus 12 plus 9 minus 3, and this is minus 24 plus 18 minus 6. All right, minus 12 plus 18 minus 24 plus 18. Okay, all right, minus 6. So here you see what adjoint of A into B is not equal to 0. So what would you say here? The system of linear equation is inconsistent and it has no solutions. All right, inconsistent and no solution. Let's move to the next question. The next question is the value of alpha in which system of equation, here given x plus y plus z equal to 1, x plus 2y plus 4z equal to alpha, x plus 4y plus 10z equal to alpha square. Okay, is consistent. Okay, consistent, it is given consistent. So we need to find the value of alpha. Okay, find alpha. Okay, so how would you find it? So if you want to find this, you need to first find, this is the system of linear equation. Here A equal to the coefficient of coefficient matrix 1 1 1 1 2, the coefficient of y 1 2 4, coefficient of z 1 4 and 10, 1 4 and 10. Okay, and what is the variable matrix? Okay, it is x y z. What is the constant matrix? B is 1 alpha and alpha square. So you know that it can be written as Ax equal to B now. So check it, 1 1 1 1 2 4 1 4 10. All right, now it is consistent means and what is this? It is homogeneous or non-homogeneous? It is non-homogeneous because here B is not equal to 0. Okay, so it is non-homogeneous. B is not equal to 0. We need to find it is consistent. So we know the property. If it is consistent, so determinant of A, what? If it is consistent, then determinant of A should not be 0, or the determinant of A equal to 0. Okay, so we have both the cases, because in the case of if determinant of A is not equal to 0, it is also consistent. If determinant of A is not equal to 0, then we have to find the value of what? Adjoint of A into B, if it is 0 or not. Okay, so if it is, in this case, if determinant of A is equal to 0, so we have the case if adjoint of A into B equal to 0, then we can say that it is consistent. Okay, here consistent also. So we have two cases. Determinant of A is not equal to 0, it is also consistent, and uniquely it has unique solution. So we have to check whether your determinant of A is 0 or not first. So let's check it out. Determinant of A, how? 1 1 1 1 2 4 1 4 10. So first we write plus, minus, plus. So first write plus 1, remove this row and this column. What do you get? 2 4 4 10, 2 4 4 10. Then you write what? Minus 1 here, minus 1. Okay, remove this row and this column. What do you get? 1 1 4 10, 1 1 4 10. Okay, write plus 1, remove this row and this column. 1 1 2 4, 1 1 2 4. Now solve this. 1 left cross minus 20 minus 16, 20 minus 16, minus 1, 10 minus 4. Okay, and plus 1, 4 minus 2. So it is 4 minus 10 minus 4, 6, minus 6, plus 4 minus 2, 2. So here you get what? Determinant of A is 0. So in this case, if determinant of A is 0, we need to find what? Adjoint of A into B. Now, my God. So we have this case over. If adjoint of A, and you know that you don't have to find adjoint of A into B, because you know that if it is consistent, you have found this determinant of A is equal to 0. Now you have to apply here this relation. Okay, this equation, adjoint of A into B equal to 0, since it is given that this system of linear equation is consistent. All right. So what do you have to do? Adjoint of A into B equal to 0. So you need to find the adjoint of A. Okay. So how do you find this? So in order to find adjoint of A, you need to find the cofactors. Again, how do you find this? Cofactor C. Okay. So C11, C12, C13, C21, C22, C23, C31, C32, C33. Okay, how would you find this? So if you want C11, so what is C11? So better formula I use here. C1 is minus 1 raised to power 1 plus 1 and the minor. Okay, the value of minor after removing what? The first row and first column. The first row and first column, what did you get? 2 4 4 10. Solve it. 10 to the 20, 4 4 16. 20 minus 16, it is 4. How is it? Okay. Now C12 minus 1 raised to power 1 plus 2. Okay, and the determinant of sub matrix, we call it minor. After removing, this is the place C12 means remove first row and second column. What would you get? 1 1 4 10 right here. 1 1 4 10. Solve this. 10 minus 4 6. Okay, right, 6 here. Again C13, how do you find C13? C13 would be minus 1 raised to power 1 plus 3. Okay, and the value of minor here after removing what? First row and third column. So after removing first row and third column, what would you get? 1 1 2 4. 1 1 2 4. So find the value. 4 minus 1. 4 minus 2, it is 2. Here you write here 2. It is so easy. Now you need to find the C21. Again C21 minus 1 raised to power 2 plus 1. Now you have to find the value of what? The minor, the determinant of the sub matrix minor after removing second row and first column. Second row, first column, what would you get? 1 4 1 10. 1 4 1 10. Solve this. 10 1 are 10, 4 1 are 4, 10 minus 4 6. Alright, in this way you can solve all. Okay, so I have solved it. I have the value also, so I am going to write it down. So it is what? So what about this? Minus 1 raised to power 1 plus 1. So minus 1 raised to power even power will be negative, will be positive. Minus 1 raised to power odd will be odd number, would be negative in this case. So we have the solution here. 4 minus 6 2. Okay, I am writing here 4 minus 6 2. 4 minus 6 2 minus 6 9 minus 3 minus 6 9 minus 3 and 2 minus 3 1. 2 minus 3 1. This is 4 minus 6 2. Okay, sorry. No, it is not cofactor, sorry. 4 minus 6 2. 4 minus 6, it is actually the adjoint I have written here only. Again, so it is what? 4 minus 6 2. I have to transpose it first. So 4 minus 6 2 minus 6 minus 6 9 minus 3 and 2 minus 3 and 1. Oh, when you transpose it, you get the same value here. Okay, all right. So when you transpose it, adjoint is actually here. Adjoint is actually the transpose of cofactor. So when you transpose the first row will become the first column. So it is, I think, same. Minus 6 2 minus 6 9 minus 3 2 minus 3 1. 2 minus 3 and 1, same value. Okay, all right. What is B? B is the constant 1 alpha and 1 alpha square. 1 alpha and alpha square equal to 0. Matrix 0 0 0. All right. So solve here multiply this 4 alpha. So here 3 cross 3 matrix, 3 cross 1 matrix. Here what would you get here? This is same. So you would get this what? As order 3 cross 1. So 3 cross 1 is the order here. So when you multiply these, okay, so what would you get? Here the row 1 will multiply with the column 1. The product will be here 4 alpha 4. The equation will be, we can write here 4 into 1 plus minus 6 into alpha plus minus 6 into alpha, it is minus 6 alpha plus 2 into alpha square equal to, here it's not equal to, sorry, because you get the product in order what was that? 3 cross 3, here 3 cross 1. Okay, the 3 cross 1, that means it has 3 rows and 1 column. Okay, now the second row will be multiplied with the column here minus 6 alpha minus 6, sorry, not alpha, plus 9 alpha plus 9 alpha minus 3 alpha square, minus 3 alpha square. Again, third row will be multiplied by this column, 2 into 1, 2 plus minus 3 alpha, here minus 3 alpha and plus 1 alpha square, like this. Here equated with 0, 0, 0. The order is 3 cross 1, okay? Since you know that the order is 3 cross 1, then the orders are same, then this can be equated. So equate only first. Here 4 minus 6 alpha plus 2 alpha square equal to 0. Similarly, all will be 0. Solve only this, okay? So it is 2 alpha square minus 6 alpha plus 4. It is quadratic. So here what would you do? Take common. When you take common, alpha square minus 3 alpha plus 2 will get here. When you factorize this, so how would you factorize? You can middle term splitting, okay? Minus 2 alpha minus alpha plus 2 equal to 0. Take alpha common, it would be alpha minus 2 minus 1 common alpha minus 2. So we get here alpha minus 2 and alpha minus 1. So alpha equal to 2 and alpha equal to 1 is the answer. Alpha equal to 2 and 1 is the answer. So I hope you have understood this. Thank you very much for watching this video, and in the next class we'll do the determinant. Thank you very much.